أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم رب اشرح لي صدري ويسر لي أمري واحلل عقدة من لساني يفقهوا قولي رب يسر ولا تعسر وتمم بالخير. Assalamu alaikum warahmatullahi wabarakatuh. So today our lecture of linear control system is 13. So in today's lecture we will discuss about the realization of state models from the transfer function. So as the title suggests that if we have the same transfer function, since we know that this state model is not unique for a system, so by manipulating differently this transfer function, we can have different forms of the state model, different state models that we can obtain for a single matrix, for a single system. So it means that state model that we have already discussed that it is not unique. And depends on the choice of choice of state variables. So it means that if we have given some transfer function, so given transfer function, many state models can be realized using different methods of processing the transfer function. So for given nth order system, we have different matrices, just like system matrix is if n by n matrix, and the input matrix is n by p matrix, where p is the number of inputs, and c is q by n matrix, and where q is the number of outputs, and the d is the feed forward matrix, which is q by p. So the number of elements in these matrices, the number of elements in these matrices can be found in the A, B, C and D matrices is equal to n square plus np plus qn plus qn, which is normally a very huge number. So that's why we want the minimum non-zero elements in our matrices. So that's why we call it as the matrices that having minimum number of non-zero elements are called canonical forms. So with the minimum number of non-zero elements, the matrices obtained in that form are called the canonical forms, and these are convenient in analysis and design of physical systems. Okay, so they are obviously very means to work with them is easy, so that we will see how we can use them. But this is the basic definition of these realizations of transfer functions that we obtain, the realization of the state model that we obtain from the transfer function. We call them the canonical forms or the standard forms, and they contain the minimum number of non-zero values. So sometimes in certain canonical forms, canonical forms, the state transition, the state transition matrix can be written down by just inspection. So that we will see how we can write certain canonical forms by inspection. So mostly that we will be looking for the canonical forms in this subject are that we will discuss in this subject are controllable, controllable. I'm right. Sorry for the spelling. Controllable canonical form. Second one is observable canonical form. And third one is diagonal canonical form. And the last one is the Jordan canonical forms. So we will see these canonical forms in this course actually. So let's look at the first one, which is the controllable canonical form. So controllable canonical form, how we will obtain it? Let's understand this thing by solving an example, so that will be more easy to understand. So let's look at an example. So we have given the transfer function y of s over r of s, which is sometimes written as g of s. So that is 2s plus 5 over s square plus 7s plus 10. So what we will do is we will write it in we'll do just some manipulation to obtain it in the controllable canonical form. So what we will do is 2s plus 5 divided by s square plus 7s plus 10. So we will multiply it 10 over and divide by ws, which is just a random transfer function. So we will draw it in the block diagram to make it more interesting. So here we have r of s, and then we have w of s, and then we have this y of s. So that will be 1 over s square plus 7s plus 10, and then it will be 2s plus 5. So ws over r of s will be 1 over s square plus 7s plus 10, or we can write it as r of s is equal to s square plus 7s plus 10 into w of s. So if you just take the inverse Laplace transform of this function, so that will be taking, just we'll write it here, taking inverse Laplace transform. So what we will actually get is r of t will be equal to w double dot plus 7 W dot plus 10 W. Now choosing the state variables, so we say that let x1 is W and x2 is equal to x1 dot, which is equal to W dot, and W double dot is equal to minus 7 W dot minus 10 W plus R of t, or it will be minus 7 x2 and 10 x1 plus R of t. So this is x2. So using this x2 and x which is equal to say x1 dot, sorry, this is x2 dot, so this is x2 dot is W double dot, which is x1 double dot. So x1 dot is equal to x2. So now we have these two equations, so we will write it in the matrix form. So x1 dot x2 dot is equal to so minus 10 x1 dot is this 0 1, and this is minus 10 minus 7 times x1 x2 plus this is 0 1 times R of t. Okay, so this is now we have the system from the transfer function. Now the output equation, for the output equation we have y of s, which is equal to 2s plus 5 times w of s. So taking inverse Laplace transform, inverse Laplace transform, so what we will get, y of t will be equal to 2w dot plus 5w. So w dot is x1 plus 2 w dot is x2, so 2x2 plus 5x1. So in the matrix form we will write this equal to 5 2 x1 x2. Now this is the special form of this system matrix here. This is matrix A. So if we look at this matrix, we can see that we have this last row as non-zero rows, and if we have means order is 2 or it is 2 by 2 order. So if it is 3 or third order or fourth order, so what we'll get is all zeros and ones in this upper part of the matrix, except in the last row we will get the non-zero elements. So this form of the system matrix is known as the controllable canonical form. So in this form actually, this whole two equations actually they are called the controllable canonical forms. So how we will use these canonical forms and what this controllable means, that we will study in the means later chapters, where we will see that if we want to control our system, so how many states of the systems are accessible to us, so that we can have the good control of our system, so that our control system is obviously the best one. So I hope you have understood so far. Still, if you have any questions, please feel free to ask in the comment section. May Allah bless you. Assalamu alaikum wa rahmatullahi wa barakatuh.